Assalamualaikum and a very good day. We are from the Diploma in Computer Science program CS110 presenting our final project for CSC189 Object-Oriented Programming. Our project is titled Pickup Order System, a Java application designed to assist food and beverage businesses in automating and streamlining their daily order management. This presentation outlines our system development following the strict criteria of the assessment rubric. Our project team is structured into 4 core operational roles to reflect real business management. AHMAD AIMAN acts as the owner, overseeing business operation, monitoring system performance, and making strategic decisions based on sales data. MOHD NAQIB AL-AMIN takes the role of sales personnel, responsible for entering custom orders, running the static queries for menu availability, and updating queues. ABDUL HAFIZ serves as our secretary, organizing the digital database registry, maintaining operational order records, and compiling administrative data. DARWISH is the accountant, managing financial analytics, calculating total and average sales, and generating revenue metrics for management. In main food operations, staff face 5 critical bottlenecks. First, tracking order during busy peak hours cause major delay and queue errors. Second, tracking the exact volume of total daily orders is highly unreliable. Third, management struggle to pinpoint the exact best-selling menu items. Fourth, custom frequently order items that are actually out of stock. Finally, compiling total and average sales manually at closing time is exhausting and prone to error. Our proposed automated system directly addresses these issues by embedding specific programming algorithms. A sorting algorithm organizes active orders chronologically by queue number. A counting algorithm tracks exactly how many total orders hit the system daily. A maximum algorithm instantly analyzes sales data to pull the top best-selling item. A searching algorithm scans data fields to throw alerts if an item is unavailable. For instance, if a customer orders a set of nasi lemak, a quantity of 4 multiplied by a unit price of 5 ringgit yields 20 ringgit. The system processes this map for every single object in our data array to automatically display precise total revenue and average speed metrics. To ensure project success, we established 3 primary objectives. Objective 1, to maximize staff workflow efficiently by developing a systematic sorting mechanism that sequences customer pickup orders by queue number. Objective 2, to improve inventory visibility by executing dedicated searching and maximum value algorithms to verify later menu availability and isolate top performing products. Objective 3, to guarantee financial tracking accuracy through automated counting and arithmetic loops that generate instantaneous total and average daily sales report.
Moving on, the scope of our project. The scope of the system covers 5 classes: food menu, order, customer, self-pickup, and delivery pickup. There are 3 relationship types in our system. The first one is inheritance between order and 2 subclasses, which is self-pickup and delivery pickup. Other than that, composition between customer and order. Lastly, aggregation between food menu and order. For the use case diagram, staff as the actor with 9 use cases, including inclusion and extension relationship. The system runs as the console application with data loaded from 3 input files. This is our class diagram drawn using draw.io. The order superclass has 3 private attributes, which is order name, quantity, and FM. FM is the food menu classes. This order complete with a constructor, 3 setters, 5 getters, 3 method per process, and a 2 stream method. Self pickup extends order and adds a queue num attribute with a constructor, 2 setters, and 1 getter, calculate price, and 2 stream method. Also, delivery pickup extends order and adds a staff name, staff phone, delivery status, and deliver log attribute with a constructor, 5 setters, 4 getters, calculate price, and 2 stream method. The food menu class also has 5 attributes, which is available, menu name, stock, price, and sold, and methods for sorting by category and state best food. This diamond shows the aggregation relationship, and food menu is associated with an order through the FM attribute, but both can exist independently. Next, the customer class has 3 attributes, which is customer name, customer phone, O for order, and method for sets and get, also modifying quantity. This diamond shows full black stated that is a composition relationship, and order is associated with customer through O attributes. Both exist dependently, neither each other. Moving on, our use case diagram. Our use case diagram has 1 actor, the staff. The use case are add customer, manage order queue, process order, manage sell report, display information, and determine best selling food. 6 use case in total. We also include the relationships, process order extends cancel order because order can be cancelled when needed. Other than that, orders also includes calculate price because the calculation always view on order list. Lastly, order includes check menu availability because availability of food always need to be checked to proceed the process.
To the input file, so our project, the pickup of the system, have 3 input files. The first one is list menu. It contains food menu and object with 5 semicolon. Separate field. For example, we have true, which is represent the status as a boolean, and nasi lemak as a menu name, 20 as stock quantity, 6 ringgit 50 cent, it is a price, and 15 is the number of items sold. The system automatically updates availability based on stock available. Next, we go to the list customer. This contains a customer record with 2 semicolon, and which is customer name and customer phone. For example, we have SYAHMI as a customer phone, and the number as a customer phone. So here we have 5 customer record: SYAHMI, DARWISH, HAFIZ, NAQIB, and Firdaus. Each customer object creates and own an order, which is demonstrating a composition. And the third one, we have this order. So this order record that reference menu item. Each order has order name, quantity, and a food menu reference. The food menu is passed into the order constructor. This is a demonstrate aggregation. Orders can be a base order, self pickup, or delivery pickup.
So my topic is class application file IO and array of object. So let's go into it. The main application drive class for a system is named main. At the very top of our execution timeline, we analyze three distinct array of objects. There is food menu array designated as menu ARR to manage our stores, culinary catalog, a customer array name, customer ARR to register buyer profile, and a core order array name order ARR to keep track of current transaction, each constrained to a capacity of 15 record and tied to individual integer counter index. To extract our application state from storage, we construct a sequential data pipeline using a buffer reader wrapping around local file reader instance. This application stores data file line by line as its process list order text. We implement data tokenization using a string tokenizer mapped to a semicolon delimiter. A conditional factory logic inspect the token count remain on each trace line. If it detects a single remain token, it recognizes it as a code number and instead a standard self-pickup child object. If more tokens are present, it dynamically constructs a conferences delivery pickup child object, each shipping address and contact parameter. Both unit types are seemingly achieved into a structure order ARR parents container, demonstrating how an inheritance framework let us manage diverse workflow inside a single unified data array. So next topic is inheritance and polymorphism. So let's explore how the structure inheritance play a pivotal role across our active user choice. So under choice 2, we must sort two distinctly different categories of orders stored inside our general array. Because parent reference cannot read subclass exclusive parameter, we analyze the instead of operator to across exam. So next topic is inheritance and polymorphism. So let's explore how the structured inheritance play a pivotal role across our active user choice. Under choice 2, we must sort two distinctly different categories of orders stored inside our general array. Because parent reference cannot read subclass is exclusive parameter, we analyze the instead of operator to across exam the underlying object type at runtime. Once a match is confirmed, we perform a split down testing, safely narrowing the object type down to a self-pickup reference to execute sorting by get put num, or down to a delivery pickup reference to successful map deliveries using specialized attribute like get delivery log and get delivery status. So now, immediately following the sequence, look at choice 3, where we generate customer receipt. Here, our application runs and automate loop directly across the indicate of order ARR to invoke the calculate price. Method tools systematically evaluate what each patron owns. The program successfully process distance financial structures by calling the share method signature, retrieving the correct pricing rule defined by the child object across our inheritance hierarchy. More sequence. So as our program boosts up, all the internal text database are created and read directly into memory buffers. The system introduces the restorer management dashboard, explicitly providing 5 system capabilities designed to map out for elimination goals. If we select option 1, it will trigger an interaction loop across our menu ARR or putting item name pricing in RM and present stock condition where user enter a search query. Our search algorithm scan our collection to quickly verify whether the specific selection is currently available or out of stock. Next, if we select option 2 to process our logic stick by leveraging instead of filtering, our system isolates self pickup transaction to execute an SND bubble sort by ports number while delivering tasks are separately processed using a alphanumeric bubble sort organized by order put strings. If you choose option 3, the backend evaluate customer bills. The program interact the true active order placement, execute calculation, logic to append necessary merits, print a itemized checkout receipt for each buyer, and compile end of days financial overview detailing total sale volume, gross revenue, and customer checkout average. By engaging option 4, the program analyze and optimize loop across our array. It evaluate the unit sold track field of each menu object again one other to identify and showcase to the top performing products. And finally, we select option 5 to close our session before shutting down operation. A print writer pipeline export snapshot of our activity menu and transaction array directly into an external system log text file by executing 2 string text down. The application then sign off with a friendly goodbye message. Last one is reference. So we refer to W3 School, Git for Git, SYAHMI Notes, and mkyong.com. This reflects a commitment to academic integrity and ethical use of digital tools. So That's all from us. Thank you and goodbye.